All right, let's get to this. So we are doing Unit 14 of the Linux Systems Administration. We're doing it live like we do all of our recordings. So we will talk about the topic for this week is Ansible automation. And this is probably my favorite topic in systems engineering and systems administration because this is probably the thing that I have excelled at the most. And this is probably the thing that has helped me the most in my career. So this really is near and dear to my heart, and I think that this is a topic that if some of you really want to invest the time and get good at this stuff, this will affect every other area of what you could learn. Like we did a meeting yesterday about this, and I had a guest speaker, Michael Pessa, come in, and he talked about kind of the ways that low-level systems understanding have helped him, but all of his automation talk was around kind of how this all pieces together. So let's talk about Ansible and Linux Systems Administration. So we are in Unit 14, so this is our 14th class meeting. We're almost at the end. We've got 2 more to go, and then the course will close out on January 19th of 2025. So if anybody wants to get that nice, cool little, not placard, but like certificate, that's only going to be available this one time. Anybody else that wants to get it, you're going to get a different certificate. There's only going to be one for the original course. People trying to catch up, you can catch up, but it's probably about 6 to 8 hours a week worth of work, and we're up to our 14th week now, so you can go do some math on how much we've put into this. We've put a lot of time into this course so far for the people who have kind of stuck through it. You can join at any time. You can do any or all or none of it. It's all free down in our Discord. But I just want you guys to know that only the people who finish the whole course are going to get the certificate. So think about that as you allocate your time. All right, so last week, which really I just recorded a few hours ago, but we did meet last week, and we did meet this week about these topics, so we're just kind of catching up on the paperwork. For Unit 13, we talked about hardening systems, and hardening systems is kind of this idea that there's this security dichotomy. There's a saying in the systems world where security is the enemy of productivity, and it's kind of a true statement. I mean, you have open access to all things, and then you have closing that down in some way. You have an open way to walk through, or you have a wall or a door or a gate or something in all systems. From the very first time somebody built up a wall and put a shelter over their head, there's some kind of way to stop people from accessing your systems, right? So the discussions for last week dealt with, there's a security team discrepancy in some of your prod servers. So you're looking at your production servers and you're doing discussions around how you would verify that problem and keep it from happening again. And then the other one was kind of building a new hardened image. And that discussion directly relates back to some labs that I've put together that kind of show you how to look at what is there and then think about how you're going to harden a system that you build in the future. Now, that's more of an engineering task, but in that discussion, the post is set up where, you're getting more and more tasks from your engineering and architecture teams. So they're getting ready to move you over into an engineering type role. So you need to learn how to do those tasks. All right. There's a worksheet for last week and a lab for last week. And then the project, I mean, if you're doing the project, you should be finishing up now. There's 4 sections of the project that you have to do, and you should be able to run through those. All right. So let's get into the course proper. Well, actually, last week was that. So this week is dealing with Ansible for automation, right? That's the whole point of it. There's going to be some inventory talk. There's going to be some ad hoc commands. There's going to be some playbook testing to see if you can get some of this stuff to work and actually cause the change you want in your environment. Now, I know a lot of you guys have been using Ansible, and some of you have even joined the professional Linux users group to get involved more with Ansible, and that's fine. That's a great thing. But I kind of want to use this week to solidify some of that for you guys, all right? So, make sure you're taking notes and reviewing material. The lab this week has already been posted, so you guys can see that and your discussions. That's all down in the project section of our Discord, right? Again, completely free. Here's Discord if anybody wants the link. We don't charge anything for Discord. You just kind of hang out. If you don't want to do the project, but you still want to hang out with everybody, that's fine. If you want to go in and take all the project material and then run away like a cartoon villain with a little sack over your shoulder, I don't care. If you take all the material for the course but never do it, I mean, I don't care. You know, it's this is for you guys, right? This is to show you guys that you can do this stuff professionally. Hey, Akshunya, how's it going? We're just working through the I don't know what my closed captioning is saying, but let's get into it. So, topics of the discussion this week. What is Ansible? How does Ansible work? How is it different? Let's do one of those comparison things. We learn even from a young age that sometimes the best way to learn about something is learn what it's not based on things you know, right? So we'll talk about what is Ansible. We'll talk about installing your tools. A huge part of automation, what I call a barrier of entry to using a tool, is getting it installed. You guys ever tried to use a tool and like you go to the GitHub page and it's just this big hot mess of like, and now you got to do this and then you got to do this, and you're like, you know, status quo is good, because there's always in engineering, there is always the option of just not doing anything and letting this thing careen off a cliff, right? Now, sometimes that's less tenable than others, but my point in saying that is when you're looking at a new tool, sometimes you go, that's too hard to implement. So let's talk about installing our tool, getting our tool working. When you get one run of a system, like when you get something to work once, I'm convinced that's the start of all the other things for you guys, right, in the systems world. So we'll install our tool. We need to understand inventories. We need to understand how to build inventories. We need to understand how to go reference and ensure that our inventories are right, because inventories can drift just like systems can drift. New things get built, but they don't get put into your inventory. Well, how are you going to figure that out? How are you going to test that kind of thing, right? And then there's running your workloads. Like once you've determined, you've got the tool working, you've got your inventory, what do you want to run in those environments? What do you want to test? What do you want to do? You need to know how to use your tools. I tell you guys this all the time. Then we're going to talk a little bit about what I call the central problem of systems engineering. There's it's almost like a philosophical way of looking at problems where you say, okay, there's all these problems that happen as a systems engineer and as a systems administrator. We're kind of focusing on this from a systems engineering standpoint, but it's all valid down to administration. But one of the ways that we look at things is there's all these problems that happen, right? But there's a central problem. There's this one thing that kind of, if you latch onto it, you can solve all those other things because it's the central problem. And the central problem of systems engineering, especially building and hardening systems from our last few labs, is consistency and timeliness. And I'm going to show you that and talk about it. And then we're going to talk about how Ansible fits in and does all of these different things. So that's kind of my layout for this week. That's kind of my talks and my thoughts on this. I stole some of my stuff from another talk that I've done years ago about automating with Ansible and using Ansible as part of a production pipeline. So I'm going to show you guys some of those pieces, and then we're just going to do some Ansible, right? One of the things I struggled with this week, and I mentioned this down in our Discord, is I literally have 50 plus labs on Ansible out there. So the hands-on part of Ansible and going and just typing things in and getting it to execute and all that stuff, I have what I would describe as a plethora of many things for you to go do if you just want to learn how to execute basic things. The focus of this week and this course, the Linux Systems Administration, is how to integrate that. So where I want to go with that, what I mean is the stuff that we're talking about here is like a little microcosm of all that. And then if you want to go spend another 40 or 50 hours and become an expert on Ansible, we have a lot of stuff that'll push you into that role. I'd say it takes more than 40 or 50 hours to be an expert, but we can get you at least using it professionally, which is, again, the goal. And Jerry, thanks for the follow. Let's get into this. All right, so what is Ansible? Ansible is a configuration tool. It runs agentless in an environment. In fact, it sits there inert on your control nodes of whatever type. By default, for Linux boxes, it uses SSH protocol, port 22. You can change that. You can change the port. You can change the protocol that it uses, but that's default. For Windows, if you're going to connect into Windows machines, which I've told you guys I have been a platform engineering lead over Windows as well, we'll use WinRM, which is 5985, and then there's a certificate version, which is 5986. Not really much more important than trivia. But Ansible's great for kicking off your PowerShell scripts and applying group policy and that kind of stuff to systems. So good. It calls modules that can be individually added or removed from execution in what we call playbooks. All the modules are super easy to go look up. They're all written in Python, and they use Python conventions. So it's all Python-esque with filters and is not and those type of almost like high-level language, free-flowing stuff. Modules exist that allow Jinja 2 templating. So Jinja 2 templating is also based off of a very Python-esque type, but it is its own little templating language. We won't get into that much for this week, although there is a project that one of the discussion questions requires you to go look into that a little bit. Jinja we can send out to email. We can send to Slack. If you guys are doing the course, you're going to be writing stuff into our Discord. So I send stuff professionally out to Slack every day. I often send things out to Discord. Some of you guys that are in our Discord see me write to Sandbox every day. I don't do that manually. That's all automated within my system. Actually, I turned that off this morning because I wanted to, we're going to modify that for the next few weeks coming up. So that's going to be changed a little bit, so we might not see that anymore down in our Discord. But you guys are going to be able to write out to our Discord this week. All right. So installing your tools, right? Ansible's one of the, it's part of most operating system repos, so you're going to find it when you just do like a DNF. Back in the day, you used to have to install EPEL repo for, EPEL is the extra packages for Enterprise Linux. You used to have to install that, and then you'd get Ansible. But now Ansible's in all the Ubuntu repos, all the Red Hat style repos, and for sure it's in the Rocky repos because that's where we're going to find it. So we'll do that. Once you get the install, you'll go ahead and do like Ansible -- version, or you could do Ansible - and then hit tab, and you'll see all these different things that got installed with Ansible, and there's a bunch of stuff that you can go look at there, right? If we were to pull that up on a system, I'm on Rocky here, and I can say Ansible -- version. I have Ansible installed on the system. It's 2.14.14. If I were to say DNF, what provides Ansible, I would see that it was installed on this system through DNF, and DNF went and got it from this package. We'll see the package repo right here. Well, as soon as the box responds. Taking its time. Doesn't normally take that long. All right, there it is. So that's where it got it from, right? We see that it's already installed, and we see that, so we don't really need to do RPM-QA for Ansible, but we could if we wanted to see that it's there. And there's just a bunch of stuff. If we wanted to see where Ansible files were, we could do an RPM-QL, and we can see what package files. There's just all kinds of things that we can do inside the system to figure out more about our tool. We can read about the modules in Ansible, right? So I can say Ansible -- a dash and then a bunch of tabs, and I can see that there's a doc, and I can say, well, tell me about the copy module. Tell me the documentation around it, and it'll tell me about the arguments that I could give to the copy module right here to cause copy to behave in different ways, right? So I've got Ansible on my system. That's a good thing to verify. Remember the first thing I said you have to do is be able to install Ansible? There is a lab. I have a lab out there on Killer Coda that shows you how to install Ansible. If you need help, it's apt install Ansible. Or in my lab, DNF install Ansible, right? All right, so super simple nowadays. It's most of the operating system repos. You can build it from scratch if you want. You can go download it and build it. That's its own little adventure, but it's not super difficult to do. All right, so Ansible uses INI or YAML files for its inventory. There's no other option there. Your inventory can include server names, IPs, wildcards, or even variables that are out there. You can apply, I don't think there's even a limit to the amount of variables that you can apply to a server. I only ever apply ones at that level that are interesting for the entire environment. So like the production or dev, the application type of the server, like is it a web, is it an application, is it a database? So like what is the server there for? But I wouldn't put things down in there like like specific versioning type things. That just seems like, even though you can put things in every, in an inventory, I wouldn't necessarily think you'd want to put everything like that. Large, if you have geographical areas that you want to group your servers by, you can do those in inventories as well. There's a lot to that. Okay. If you're like, well, Scott, I want to dig in a little bit on inventories. How do I do that? Well, you come over here to Ansible inventory, right? And you go look in the inventory documentation. You always come up here and you make sure that you're on the right version. So maybe 2.9. But see, if there's no change between the version you're on and 2.9, you can do that. And then we'll just go back to latest. There we go. Here's our basic little Ansible inventory right here. And as I said earlier, let me link this for everybody. As I said earlier, you can come in here. There's only two input types. There's the .ini format, which is this, and the YAML. I prefer the INI format for a reason that we don't need to dig into too much right now, but it's mainly because I generate my inventories. I'll go hit things via API calls and pull down and generate my inventories. I do that out of either like a CMDB like ServiceNow or through Red Hat Satellite. Satellite's got a pretty good little handle on all my servers in my environment. I can also pull it out of like cloud inventories and those kind of things, right? Okay. So, we can put whatever we want into our inventory. And then we can run workloads, right? So you can do ad hoc one-off commands where you just call a module. There's no memory passing or variables really being kept. And, you just go off and kick off an individual ad hoc command. Ad hoc commands are probably one of my favorite administration side of the house tools. So when I'm doing systems administration, as opposed to like pipelining and building like we're going to talk about here in a minute, and I just want to go like check a bunch of servers are up or down, right? You guys have seen me do this in the lab a lot, right? I'll just be here and I'll be on this werewolf machine and I'll just say like Ansible. And look, yesterday we wanted to remount opt for a certain reason. Don't worry about why we remounted opt. It was for the hardening part. But I could just hit all of my servers in my environment with an uptime and just see how up all my servers are right now. How long have they been up? Are any of the servers not responding? Is there any users on the servers? What load are they under? I can see all this stuff right here. Boom. So those are the 19 Rocky boxes that we have for our lab environment, which anybody that's doing this course can run through. But that's an ad hoc command. That's a quick little sysadmin. And you might say, well, Scott, couldn't you have done that with like a, couldn't you have like looped that? Yeah, guys, we could do this, right? We could say for I in sequence 1 to 19, do SSH to Rocky $I uptime done, right? We could do that. This'll do the same thing. It's a few differences. We don't need to get into all the differences, but the main ones are, this is doing multiple in parallel. This is doing them serially, one at a time. So if this had hung on any, it would have waited. This would have only hung after 5, but that's because of the default number of forks. We don't need to get in too much to that. But can I tell you that you're getting the same information, it's just this has more control around it. But an ad hoc command, really the usefulness of it stops there. If you were to say, hey, Scott, could you push this file to 100 of my servers? I could do it pretty quick with an ad hoc command. But if you said, Scott, I need this to be done now on these running servers, and then could you build it back into your pipeline that goes and deploys as servers get built? I would say yes. Now I have to take that little ad hoc thing I did, and I need to make it into a task in my playbook as I deploy my servers. So this is great for one-off in a running existing Ansible like operations environment, right? This is where we go back and turn it into part of our production running. You're going to see here in a second how Ansible is kind of helping us get to like a DevOps type, I guess, posture, right? Because I came up on the systems admin and systems engineering side of things. I've been building Linux servers for 23 years or whatever professionally, but then this other side comes in where it's like, we need to build them better, we need to build them faster, we need to be more consistent. So let's talk about that a little bit here. Here's the central problem of systems engineering for servers, for sure. And it's this. It's consistency or repeatability, and it's timeliness. Now, have any of you guys heard anything like this? If you haven't, well, welcome to being a systems engineer. But Steve sets up a server build procedure, and he hands it over to Dave. So Steve's a senior guy, Dave's a junior guy. Dave builds the servers, but he hasn't gotten the updated file location, so now you have a bunch of different versions and conflicts in server software. This is the old hands-on, you get a server, you pull it out, you rack stack it, put it in the actual environment, and you build it from scratch, right? This is less common nowadays. Most of it nowadays is we'll deploy an ESX host and then maybe do some configurations on it. But the top one up there, Steve's updated the procedure, but he hasn't sent the new one over to Dave. So there's all kinds of problems here. We're building it by hand. It's a busted procedure. Every server is coming out as a snowflake. It's unique. It's ready. It's different than all the other ones. That's terrible in the server world. We want everything to always deploy exactly the same, right? Then there's also timeliness. Steve can kick off his local scripts and build the servers in an hour, but it takes the rest of the team 3 days. And most of the time they have to ask Steve for help. So, I said Steve, well, whatever. So they have to ask Steve for help. So these are problems. These are real problems. So let's talk about how Ansible, and there's other tools, but Ansible's the one I like, to solve this. There's a few things that people have tried over the years to solve that central problem. There's ITIL. Nothing wrong with ITIL, right? ITIL's fine. It makes us define everything as a service as far as from IT. It's no longer where people put in tickets and then we sit around and we're like, I'll get to that when I can. Now we're much more like a restaurant, and people show up and they order the stuff they want from us off a menu. I would like 4 of these non-prod servers to be delivered, please. And, really nowadays with automation, you should be able to deliver a server, on a request from your user in probably under 5 minutes for most things, depending on how mature your organization is. And that's where we kind of try to get to. Then there's DevOps methodologies, right? Like DevOps tries to pull all the hardware provisioning into like a software lifecycle methodology. Everything produces an artifact. So when you build something, its infrastructure as code, it's an artifact, and it can be repeatably run against a set of servers. And this is really where we want to be. Acceptance testance gets automated, so something gets pushed up into, a repo or something, and it automatically goes through the testing cycle. And then before things go to production, there's peer reviews or, some kind of code review type thing. And then some person has to say yay or nay to push that code up. That typically looks like something like this. This is an image that I pulled and kind of drew and put together a long time back. But the image is around dev, test, and prod environments. So dev is always spinning. Dev is always ready to deploy. You're always planning, designing, testing, building, and accepting things and getting to a new state of deployment. And each of these gets a new version, right? Like a little software version number. You use the SEMVer. And you get your major and your minor and whatever. So dev is always spinning up to new versions. But prod is always ready to deploy on whatever is up. So you don't change prod. You can do dev for weeks and maybe even months or years. And when dev finally gets accepted all the way up, and as good as we're going to do, we flip that over to be the prod deploy. So dev can change, 100 times for every one time that you ever get a prod change. Prod should always be ready to deploy from whatever the most stable and correct version of this you're on, if that kind of makes sense, all right? So the goal is to keep these iterations tight and working. Automated testing and building helps. So this is exactly how, like, when Michael Pessa came yesterday and was talking to our Linux group, we were talking about how we deployed servers. I could be sitting back here in dev, like tweaking my code and messing around with my stuff and just rebuilding a bunch of dev servers hundreds of times a day if I wanted to. But when it finally gets ready to get pushed up, and there's some build and testing and all that kind of stuff that I'm doing, but there's also some automated stuff as we're moving along. And when it finally gets good, maybe it takes me months to finally get good on my deployment, then that flips over and becomes the new deployment model for all servers going forward or whatever. Hey, Colchis and Raleigh, how's it going? We're just running through the systems engineering. Unit 14, who would have thought we'd have been this far, right? So here's another one. This is kind of one of my, this comes directly from one of my talks, but we hope the team writes good code, pushes up to Git, then Tower, or now Ansible automation platform. You can tell my documentation here is a little dated, but Tower builds, and then it can automatically build things, or it can go and look for triggers. You can have Jenkins even build things and kick off Tower. Tower has an API, so you can kick stuff off on Tower whenever you want, right? And then we report out. We report that things are good or not. And I've been showing you guys this, but this is huge. Like, the fact that things can just be happening in an environment, and we can just look and go, oh yeah, that's good. I always tell you guys, like, so I like to make sure my environments are clean every morning, because I'm the guy responsible for all of my environment, right? So one of the things I do, and you guys might think, oh, Scott does this professionally. The same thing I do in our environment here. By the way, I think I turned it off yesterday. Yeah, yesterday was the last time. This is going to run for a while. But it would go through and it would check all of our environments, and then it would tell us, like, unreachable systems. Well, we turned those off the other day. And then users that have logged into the servers. Well, nobody's been using our servers, so well, it is what it is. But I can go back, and every morning when I come in and sit down at my desk, I can see how clean my environment is. I can see if a fire started somewhere. I can see other things. Granted, look, this is not the monitoring talk. Monitoring should be doing that, but if you can't afford a 24-hour NOC, and I'm not going to do 24 hours network operations in my home lab, I can at least check the state of all the systems every morning. There's one that doesn't show up in here very often, that some of you guys have probably, if you haven't been around long, you haven't seen it. But if I reboot P01 jump 01, it always reports out here. So if my primary server that you guys jump into, P01 jump 01, you will always see it report right here when it comes back up. Because I want to know. I want to know if that server came up so I can check all its baselines, right? Anyways, all right. So Ansible fit into systems engineering. All right, so here's our lab tasks this week. So there's a whole bunch of lab stuff to get your hands on. We can install Ansible. We can verify Ansible versions, generate an inventory, run ad hoc commands, build a playbook, run a playbook, and then pull a playbook from GitHub and run it. So in the lab here, if I were to pull this up, boom, and I were to jump over here to Rocky, right? We made sure that we had Ansible. We can check, all kinds of things about it. We can see that Ansible's there. Whoops, I meant QI. Right, and we can see when it was installed. We only put it on the system a little while ago, so earlier this year, right? Yeah, installed there. Yeah, if you guys need to get access, we have a Discord. You guys could keep up. You can, and this is always going to be available. But yeah, just get in there. Look, guys, the thing about this is you're not trying to boil the ocean. You're trying to eat an elephant one bite at a time. You get in and you start where you start, right? There's no major rush to a lot of this stuff. But again, feel free to get in there if you guys want to get more involved. So let's talk about some of these in the context of the lab. So there's a lab for this week. And the lab makes you type in some basic little commands. So you would do like make dir, root, Ansible, madness, right? CD to root, Ansible, madness. Just typing practice, really. And then DNF, what provides Ansible. And what provides should be one command. That's sorry, or one thing. So now this will go and DNF will pull things. And I just have you do a bunch of different things. One of the things I say is Ansible dash and just mash the tab key, and it'll try to auto-complete a bunch of other things. So then I say, let's go ahead and just run a basic little command. What if I said Ansible localhost -m shell -a uptime? Can I run Ansible against my local machine here and see the uptime? And does that match with the uptime of my system? Yeah, that looks right. I just rebooted this box 36 minutes ago. Okay, that's what I expected. But what does Ansible do if I put a bunch of these in there? It's going to be very verbose. It's going to tell me, is this using an SSH connection or is this just connected? That's a very dark blue, I know, but it's telling me that it's just calling a new shell and in that new shell is executing some Python, right? So it's just yeah, this is just good practice right here. The warm-ups just get you touching a system, right? If you're not familiar, like some of us probably type over 1,000 commands a day, let's say. So for me, and for some of you, this is not super interesting, the warm-up part. But then the lab gets us into building some things and going through. I don't ever go through the labs really, but the lab tells you how to go connect to some of the other servers in the environment and make sure that things are working the way that we expect them to. All right, so let's go look at the other thing that I had kind of jumped over for this week. Didn't mean to, but let's talk about the other parts of the worksheet for this week. So the worksheet is the part of the kind of Linux course that tells you all the things you need to do. But you fill out the sheet and progress through, and then hold on to all your work to send to me at the end. You do not need to send these to me each week. I tried to do it for the first 3 weeks, and then we had like 200. I think we had 206 or 208 people before Discord wiped our event. So our event is only up to 66 people again. But if you guys want to join the event, you can. It's just you just go say that you're interested. It doesn't cost anything. Just go in there and hang out. All right. Anyways, enough of that. So here's discussion post 1. Refer to your Unit 5 scans of the system. So back in Unit 5, we scan the system. This was the map I gave you for go figure out all this stuff. And then what I said was make an inventory of the servers that you found any way you want to group it. So almost like this in my home lab here. I have my systems grouped as CentOS 7, CentOS 8, labs, which are Ubuntu boxes, an actual Ubuntu box, some new servers that I had built. I've got all the dungeon nodes. The dungeon nodes were for some kind of honeypot playing and games that we had. And then all of our Rocky nodes down here. And then my production K8 nodes are down here as well, which I probably need to do some more with K8s in my home lab. But anyways, how would you... Now this is different. I didn't just give you guys all the answers there. This is your view of the environment that we have for the lab. And you say, well, Scott, how did I get that? Remember I told you guys sometimes you're going to sit down in an administrator role and the manager's just going to put his hand on your shoulder and be like, oh, I'm so glad you're here. We haven't had a Linux administrator since the last guy. And it's like the chair's going to turn around and he's going to be like a skeleton or whatever. And you're going to go, well, hey, do we have an inventory of the system? And he's going to go like this. He's going to go, oh, you. And he's just going to turn around and walk out because now it's your environment. So when I tell you guys, like, you have to scan systems and figure this stuff out, this is your life now, right? You can do anything. You're a Linux engineer, right? Like that's our lives. Once people figure out that we know how to figure stuff out, that's what we do for the rest of our lives. Anyway, so make an inventory. What format did you choose? Now, you know from what I said earlier and from reading the documentation here, this is documentation, that you can group your inventory. You can make a .ini or a .yaml format. And I say, what other things might you want to include to the inventory? Are you going to add any variables, right? Now, if you're wondering where this is, it's in the Discord right here under the ProLUG project section. I just added these, and I just added the ones yesterday from the system hardening. So Unit 13 was last week, Unit 14 is this week, but I had to catch up a little bit because my dissertation work was a nightmare. Absolute nightmare. Anyways, all right, so here's question 2. You've been noticing drift on your server configurations. By the way, in the hardening lab, you got confronted by your governance, risk, and compliance team on your discussion. So now you're the one noticing the drift. And I say, so you want to generate a lab report to validate the configurations, and then you want to, you can do any of this, and then you're going to use this webhook to send out to our sandbox channel. All right? So there's that. And then the last one is I say, using the Ansible module for Git, pull down this repo. I've got a repo out there. And I said, how is the repo set up? What is in the roles directory? How are these playbooks called? And how do the roles differ from tasks? And then I would challenge you, can you get one of them working? Can you modify one of them so that the roles work properly? There are... let me pull it's from over here on the worksheet. No, it's not in the worksheet. It's in the lab. The very last thing on the lab, I think. Yeah, here's the clone. Here's the command to clone it, right? Let's get this out of the way. You can clone this down, right? And so now we're looking at it. So here's our HPC deploy directory, and you look at like the 01 NFS, and that thing is going to call a bunch of, it's hitting all the hosts, so whatever inventory we're looking at, it's going to hit all of them. So that's an important thing to understand. And then there's roles, but the roles are only going to be inherited if you meet a certain type. So now you have to have a variable in your inventory. So now you're going to have to go look at how to add a variable to an inventory for type server or client. And then now down in roles, you're going to either inherit the NFS client and oops. In here, you're either going to get the client or you're going to get the there's more main.yaml, or you're going to get the server. You're going to get one of those two based on the variables you have. And then you might say, well, Scott, what happens if I don't have that type assigned? And I say, well, one test is worth 1,000 expert opinions. You can ask me and we can sit here and argue, or you can go run it and find out what happens. I can tell you it just happens to be that nothing will happen because you're not this type client or server, so get out of here. You just bypass all the roles. So you don't inherit any roles. So this could run against 10,000 servers, and if you don't have that type of server or client in there, it won't do anything. It's a completely inert playbook that has two roles that never get inherited. You would just see skipped down the line. Would you want to do that? Oh, God, no, absolutely not. That's why inventory is more important than execution. Inventory and what we're hitting against is very important. All right, anyways. Definitions and terminology, automation, consistency, DevOps. These are all the things we just talked about. And then I want you to go and look those up, right? This is always part of our little tasks. Notes, so links and terms and useful things. Oh, I didn't pull Spider idle out, but Spider is a thing we used in one of our earlier labs. Unit 14 lab on automation, and then you're doing your project. Make sure you're getting deeper into your project. And then I say digging deeper. I have a large amount of labs to get you started on Ansible down in Killer Coda Labs. So there's, I think, 20-something labs in there. We've got a bunch of Ansible projects that people have built over time in the Ansible code channel of our Discord, so you can go in there. And then also, I have kind of a challenge lab. This is the hardest lab that I've built for people. I think it's the hardest lab. It's definitely the most complex, where you're going to go read Ansible. You're going to go read secrets out of a vault. So HashiCorp Vault gets set up, Ansible gets set up, and you do API calls to get the information out. And then I say, I always do reflection questions. What questions do you still have for the week? You can ask those down in Discord. And then how are you going to apply this to your current role in IT? And if you're not in IT, how can you put something like this on your resume or portfolio? So those are our big kind of high-level tasks for all of this for the week. All right? So lab tasks this week. There, we kind of touched on each of these. And then questions, just make sure that if you have questions, you come down to the Discord, let me know. I'm on there as Het Tanis, and most of you that have been around kind of know me. So here's the goal. We'll probably stop Het Tanis. Anyways, all right. So hop down in there and that kind of stuff. I will end the stream here to go ahead and just save this as our Unit 14, and then I will come back on probably a little later, and we'll just hang out and do. I don't know. We'll probably do some system stuff. I do have an idea for system project stuff that I want to do around kind of training engineers more on this stuff. But I have to kind of, I've got that all drawn up. I just have to go and start executing some of it. So we might build some of that for the lab later. Other than that, I guess thanks for coming by. And I will see some of you guys here in a little bit.